about it geometrically, you can see what it has to be. Like,
the intersection of straight lines from ABC through the center of that.
through the center, perhaps, but maybe not. I mean,
Relative to the sphere, it has to be through the center.
yeah, through the sphere, I'm totally on board with that. I would say that it has to be, if you look at the normal vector, you can see geometrically it must be like a normal line from the sphere out to that point somewhere, right? And if you follow that, anyway, so that, something like that. But let's, whether, I'm not trying to guess the answer here. I'm trying to figure out how to find it from method of Lagrange multipliers. So just pick a point on the ellipsoid, x, y, z, right? What do you want to minimize? You want to minimize the distance. And I say minimize the distance squared because distance squared is easier to work with. Your objective function, f, is equal to x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared. Agreed? I mean, that's what we want to make small. First of all, if ABC is actually on the ellipsoid, game over, we're done, it's closest to itself. Yeah.
Using that, it just comes out in algebra after that.
That might be. I don't know. So what we want is the gradient. I mean, the algebra can be hard. I mean, so we try to solve that, right? So we get 2 times x minus a, 2 times y minus b, 2 times z minus c, lambda times the gradient of g. Well, the gradient of g is 2x, 4y, 6z. So you can solve for lambda. You got lambda is, on the one hand, x minus a over x. It's y minus b over 2y. It's z minus c over 3z. Es bueno? I don't know. And then you do algebra. Hopefully find your way to the end of it. Keep in mind that x squared plus... What's that?
Is the ellipsoid the constraint?
Yeah. No. The distance is the objective. The constraint is the ellipsoid. Although, ironically enough, no, you need to have them straight, yeah. Because you want to be able to impose this equation, right? I'm not sure how much farther it is past here to solve it, but... I think you can do kind of something very similar to the problem we worked the other day and eliminate every variable except for one and then plug it back into the ellipsoid equation, right? Like, just to get us started, this one would give you 2xy minus 2ay is equal to 2x, well, is equal to xy, right? Minus bx.
Write those down to solve each one for one variable, plug back in.
Yeah, see, that's annoying. The xy is canceled in our previous problem. Yeah, anyway. Like I said, I have to really sit and think about the algebra past that, but... Don't, algebra, I mean, there's plenty of algebra problems we still can't solve. It's, math is not dead. People are still working on algebra. Some simple algebra problems are very difficult.
Maybe that one shouldn't be graded on algebra.
Ha! You are engineers. This is a problem. You should be able to solve it. It's just algebra. Come on. Uh-huh.
Or we get 30.
Did you guys have other questions, or do you want me to spend the rest of the class trying to solve those equations? I mean, I can if you really want me to. What's up?
So 0, 2 was the solution to that last 72 we just did.
Yeah, I think that the, I don't know what the value is of the maximum, but I'm pretty sure that it's attained at 2 points, and those 2 points are where the circle joins the line segment, I think. That's what I'd expect to find. Oh man, 74 and 75, I worked those out in class. Urgh, how dare you guys trick me into doing that? Sorry about that. Do you remember when I worked those? No? Oh, okay. Ah. Should have paid attention. No, 74 and 75, I have actually worked out the details of those.
What date did you work those out?
Well, actually, not all the details. I worked out no, I think I did. Remember we talked about if you had a connected set, you could join like a line segment. I just did 3 line segments to illustrate the idea. And we argued that on each line segment, the value of the function at the beginning and the end had to be equal. And then if you just join the line segments, they have to match up. Then that gave us that on a connected set, if the gradient of the function is 0, the function has to be constant. It was the same day we proved the mean value theorem. I mean, I did prove the mean value theorem in here. Yeah. At that point, I had forgotten that I made these homework problems. Sorry about that. I'm very proud of the bonus question here. The solution involves the Schrödinger sphere. It's one of my most proud solutions. Very proud of the solution. I need to write some more problems like that. Oh well. Anyway, yes, the algebra can be hard on some of these problems, but I hope you by now have understood the main tools that we have at our disposal and are ready and willing to do at least the easier ones of those, and to acknowledge that algebra is hard. I mean, I'm not really seeking your acknowledgement of that, but it never really gets much easier. These problems, they're kind of like, in my opinion, they're kind of like calculus 2. But then again, maybe I just haven't learned the right math yet. I don't know. You can turn it off. Thanks.